very inspiring music. Hello, good morning, good afternoon, good evening, depending on where you are on this planet. And welcome to the second Swift server meetup. I have a lot of guests with me today. We have Mikaela, we have Janice, we have Adam, we have Sven. So thank you folks for joining us. Thank you to you for watching this second meetup live. Let us know where you are located. In the comment, say hello from, I see a few names. Andrea is in London, France is there as well. France is in Germany. I saw other names as well. Let us know where you are. I can start with me. I'm not living here, but I'm in Paris right now, in a nice professional studio at the office. That's why there is a nice background and light in front of us. So UK, Colorado, Arizona, Nairobi, Kenya, Indiana. Oh yes, Indiana, it's you, Mikaela. Say, oh, second person from Indiana. New York, Czech Republic for Onza. Thank you, and thank you for joining. We have a nice agenda tonight. We have 3 parts in this meetup, just like we did last time. The first one will be Mikaela. She will show you how you can deploy server-side code on fly.io. And then Adam and Janice will make a tour with a demo. I heard there is some live demo for both of you. And the demo will be around Hummingbird 2. After that, the member of the Swift server working group will be there for you to answer any Swift-related questions, so we can keep the microphone open and go through all the questions that you have. You ask your question during the talks in the comments, and I will put the question on the screen just like that. Both Mikaela and Janice and Adam will answer your question at the end of their talk. Before the first talk, before Mikaela, maybe you noticed a few weeks ago that there was the WWDC conference. There was a lot of new stuff announced around Swift and Swift on the server. So this meetup, as I told you, is organized by the Swift server working group. It's a steering team that promotes the use of Swift on the server and an ecosystem of libraries. And maybe you watch a few sessions during the DC conference. During the conference, Apple reminded all of us that Swift is already 10 years old. Oh my God, I remember the keynote when they announced Swift 10 years ago. I think it was with iOS 8. At the time, it was not open source. It has been open source later. And there was that great session called What's New in Swift that you can watch on the Apple developer application available on TV, iOS, iPad, Mac. Also on YouTube. I saw today that all the sessions are on the Apple developer channel on YouTube. And in that session, it was like an history of the things from the past and where Swift is going next after 2024, with the big announcement, of course, of Swift 6 that will bring many improvements. And one of them is the Swift concurrency support. There was a couple of sessions about how to get ready for Swift 6. Give us feedback about Swift 6. The Swift core working group and the Swift language team is keen to get your feedback. So you can go to the forums and leave your feedback about the current feature set and the current implementation. You can try Swift 6 today. Either you download the toolchain, it runs alongside the 5.10 toolchain in Mac, Linux, and Windows, or you can also use Xcode 16. I saw that the beta 2 was released yesterday or today, and it can run Swift 6 as well. So the address of the forums is forums.swift.org. There is just a small window of opportunity in the next couple of days, couple of weeks, before they freeze the code for GA. So give your feedback as soon as you can. And if you want to migrate your code, Apple released this excellent documentation, migrating to Swift 6. The URL is a bit longer, sorry for that. So it's swift.org/migration/documentation/migration guide, but it gives you a methodology step by step how to prepare, how to turn on a couple of compiler check, how to address the couple of warnings or errors you're going to have, and how to prepare your code base for Swift 6. Another announcement from WWDC was the creation of this new GitHub organization where all the Swift open source projects will be reunited. So the language, the toolchain, the documentation, the website, but also the Swift on Server project will eventually over time migrate there. So it's one new place for everything Swift open source on GitHub. I really like the session. There were 2 sessions on Swift testing, so it's available right now. It's also included in the Xcode 16 beta. It's a new way to write a unit test with a lot of macro, and it's much easier to write tests. You can give it a try today or watch the session. And then there is all friends from the Swift Server Working Group that had very interesting session to talk about Swift on the server side, Swift on the ecosystem. He made a demo with Visual Studio Code and Vapor, and we had the pleasure to see a typical Bavarian outfit as well, really at the end of the video. So don't glimpse, because it's very fast, very quick. If you glimpse, you will miss that. I just took that screenshot. That's the one I wanted to share. But you look terrific, friends. We love it. Okay, that's it for WWDC. Let's go back to tonight, this meetup. And the first, it's for you, Mikaela. Oops, that's for later. Where are you, Mikaela?
I need to present.
You are there, but the stage is yours. I will monitor the question, and your screen is here.
Hey everybody, how's it going? So I will be talking about how to make Vapor fly. So deploying Vapor on fly.io. So this is for Swift server side, the second meetup, but I also gave a very similar talk at the server side Swift meetup that was in London in December of 2022. So this is kind of an updated version of that, but with that I'll be doing a live demo versus the one that I gave over there was like fully recorded, so this will be fun. So let's get started first. Again, my name is Mikaela Caron. I'm an indie iOS developer and freelancer. I also organize a monthly online meetup called iOS Dev Happy Hour. So you can go to iosdevhappyhour.com and then join us monthly for a virtual online meetup. And then I'm also a content creator. So I make content on Instagram, Twitter, Mastodon, Threads, you know, all the different social medias that we have nowadays. So I do that and just talk about my work with iOS development, what I'm working on, and also my own app that I'm currently working on, which also is deploying a Vapor application. But don't tell anyone, it's actually deploying it to Heroku, not to Fly. But for this presentation, let's talk about Fly. And Vapor development is pretty simple, right? I mean, all you have to do is develop your app and then deploy. Super simple, right? It kind of is. And deploying to Fly is relatively simple. I'm going to be showing you one of the most straightforward ways to do that without adding anything super crazy into it yet. But for bare bones, how to deploy something, this is like the step to go through. So first, what is fly.io? It is a scalable full stack without the cortisol. So it's that you can deploy it to 35 regions, and then it's a developer-focused public cloud. So these are all the words that I took from their website. This is what they try to tell you what Fly means, but basically anything that can run a Docker container can run on Fly. So that's just the easiest way I like to think of it as. So why use Fly? Well, as of August in 2022, Heroku no longer had a free plan, and this was kind of tripping some people up, and they're like, okay, where can we deploy for free now? But as of June 17th, so like literally 9 days ago, Fly now has a pay-as-you-go plan, which sort of kind of has a free tier. So I'll get more into that later. But Fly also, you can deploy, again, any Docker file, and I'll talk a little bit more about Docker. And then it works with several different databases. So the different databases it works with is Fly, Postgres, so their own sort of Postgres instance, LiteFS for SQLite, they have Up/Redis. In beta right now is actually pretty cool. They have Superbase Postgres. So Superbase is a Firebase alternative, and then they also have their own Postgres database. So you can like attach your Fly application to a Superbase Postgres. They have Tigris Global Object Storage, MySQL, MariaDB, a couple others. Like there's a good amount of databases you can kind of connect to. As long as you, again, have a Dockerfile, then you can deploy to Fly. So let's go into that a little bit more. So deploy via Docker. Docker is a platform designed to help developers build, share, and run modern applications. So first, your Docker file is how you build an image of the Dockerized app. So this has like your executable and all the other dependencies that you need. And then you have your Docker Compose file. So this is how Docker should build multiple services and then their kind of relationship to each other as well. So let's get started. We are going to make a Vapor app, and it's just going to be your basic Vapor to-do app. So once you go through that, do like, Vapor new in the command line, and you get this lovely animation. That is the kind of application we'll be working with. So we're not doing anything other than the to-do application that comes from like the general template. So how we work with Fly is we use the command line utility called Fly Control. So to install that, you use Homebrew, which is a package manager for macOS. So brew install flyctl. And then fly auth sign up. This will let you have to first create your account on, actually you can create your account right here, that's what I'm talking about. You can create your account here, or you could end up creating it online. But you create your account, and then you use fly auth login to actually go about logging in on your terminal command line. But first, we have to set up billing because, like I said, Fly did have a free plan. It no longer has a free plan, though. So this means that by default, if you were a brand new user today, you would have to do the pay-as-you-go plan. So this means you have to put in a credit card, and you have free limits, but actually you only have free limits if you're a legacy user. It was kind of confusing. Sorry, I'm like flipping through if you're seeing. Yeah, me switching my desktops. It's confusing because here you should, yes, be able to see me, flipping through everything. This says free allowances, like this is the Fly website, says there are free, like under the header free allowances, there are no free allowances during the free trial or on the pay-as-you-go plan. So again, that means if you signed up for a free Fly account, not even free, if you sign up for a Fly account right now, that means you do have to put in your credit card, and you technically do not have a free plan. It is a pay-as-you-go plan. But if you were a legacy user, so you jumped on Fly the second it was 2022, and you tried to get in there, you do have a small free allowance, and then that was what those list of free allowance requirements were that are right here. So you have up to 3 shared CPUs with 256 megabytes for RAM. You can have 3 gigabytes of persistent volume storage, and then you have limits on the outbound data transfer. So slightly confusing, but if you were to, again, set up a brand new account right now, you do have to set up billing. So let's just get into how we do this, because when we go back, we'll be back on the recap. So here we go. Let's attempt to do a live demo. So what we just did was create our Fly project. So we did Vapor new, our Fly project, and then, or no, it's not Fly, sorry. Vapor new and just creating the Vapor project. And then I did hello test as the name because I couldn't think of a better name. And the only thing we have to do before we actually build this is I commented out all of the default connection comments to the Postgres database, and instead added in the connection only using the database URL. So what I discovered when I was redoing this presentation was that instead of individually adding all of your database username, password, name, and like database port, database host, instead of adding all of that stuff one by one using the Fly command utility, they just give you the database URL, and that's kind of it. And you have to set this up before you even go to deploy to Fly, because this used to not happen, but now Vapor will get stuck in a boot loop on Fly if you try to deploy, but you haven't set this part of the database up yet. Like, you deployed, but then you were going to set up the database later, it just gets stuck in a boot loop because the application keeps continually crashing that it's doing that. And then you end up like, it just keeps like crashing and running out of memory like over and over again. So be sure you set up your database with this database URL, getting it from the environment. And then to again make this simple, I just did app.automigrate to auto-migrate the to-do migrations. So once you do that, we have our terminal here. All you have to do is type fly, launch, and hit enter. I have already tried this once, so what you're seeing this is it has an existing fly.toml file. So that's, you can see it right here in my project, it's a little smaller. But that is just because I've already run this, because if I didn't run this beforehand, it would have taken like, 5 to 7 minutes to actually go about deploying. So it says, would you like to copy this configuration to the new app? I'm gonna say no, because we're not copying this, but we'll make a new one and you'll see what that does. So it says scanning your code for your Docker file. It says we're about to launch your app on fly.io. Here's what you're getting. So they auto create all of these attachments and everything that you would probably want in your application. So because of that, we actually do want our Postgres database. So we do want to tweak these settings because we do want to add in the Postgres. And then you can see by default, it chose New Jersey as closest to me. It kind of is not, but that's okay. And then it gives you a default name for your application. So do you want to tweak these settings before proceeding? Yes, we do. So if we hit enter on that, it will by default then open up this web GUI. This used to be it used to be in the command line from my original presentation on my YouTube channel, so I'll have the link for that at the end. But this used to be on the command line. It no longer is. Now it's all in the web. So if we wanted to deploy a brand new application, we can, give it a better name. Let's do hello test 5, because you can see me changing all these. You can choose whichever region you would like to go with. So typically you can deploy wherever your users are like closest to, like your biggest amount of users, or just wherever you are. It's totally up to you. I'll do Chicago because technically I think that's the closest to me on this list. Whatever port. And then again, with the free limits, you had to have a legacy plan to still get a free tier, but otherwise you have pay as you go. And then their site attempts to break down the pricing. Again, I still find it slightly confusing, but here's the one CPU, and then I'll do like 512 megabytes for memory. But we do want to select Fly Automated Postgres. So this is, again, the simplest way to deploy with an app and a database. So let's select that. And then now we can give it a name. So you can see I've already given it a name like this. Let's add DB. Though I'm going to show you, it's not going to have this exact wording again. So when we do this, it will automatically create our database URL for us that are stored in the secrets of like Fly's backend. And then let's not pay for production, let's pay for deployment or development. And then again, you can choose these options now or later. You can always add everything else later, but we'll go through, and then once we hit confirm settings, it would go and create it. I'm not going to, because I have already created this, and if I were to hit confirm settings, it gives you a screen that says, hey, you've got everything done, you can go back to terminal, and then it would go through that. So I'm gonna hit Control C to like cancel this because I'm actually not going to be deploying it. But I will show you what does end up happening is that the web is a little small. Let's see if we bump that up a little. There we go. Hopefully that's a little bit better. I made hello test 3 for this example, and then hello test vapor is the name of the database. So then with this, it's been created. You can see, I don't know why this says, oh, it says suspended, I believe, because it's not technically, it's like they try to spin up the VMs like when you actually make requests versus having them always persistently running. But I think those are settings you can kind of change through. But if we click on the database, you get all of this information about your database, and we can see average memory, we can see all the different things that we want, and then going back to personal, this is the main application, the Vapor application that's running. And then one super handy thing when everything goes wrong is always you can go to live logs, And then live logs is what actually has the logs that you would typically like end up seeing in your Xcode console for when you run everything. So this is where I was looking when I was having the app like constantly in a boot loop and crashing over and over several times. But then these logs are where I kind of saw that that's why what was happening was clicking on whatever application and then go to live logs. So now that it's running, it kind of actually is just running. So all we have to do is open Postman or whichever other kind of application that you want to use. And we can do type in the URL. So what you do get off of that fly control CLI is you get the URL for what your app is deployed to. So mine's hello test3.fly.dev because that's the subdomain and it comes from the name of your project. So if I just go ahead and hit send, hopefully that took a second, says it works, which is good. That's really tiny, but I'm sorry. And then we can make a new to-do. So if I say like title, hello Swift server, hit enter. There we go. There's the title, there's the ID. And then we can do the get endpoint on /todos. And there we go. Now we have one of our to-dos. So that is actually all you have to do to literally deploy to Fly in the most simple way possible on Fly. Again, anything that runs in a Docker container, you can deploy, but that means you have to then start knowing more about Docker, which may be what you want to do, or it may not. So again, a recap of everything. You have to download Fly Control, which is through Homebrew. Don't forget to set up billing because their billing is getting a little confusing. It's only been, like a little over a week since they set everything up because they have changed everything from 2022 when I first gave this presentation up until now. But that, again, right now, as it stands, at this very moment, you have to set up your credit card to be able to use Fly. Oops. And then lastly, the only command you really have to type is fly launch, and then we come up with that web GUI that will show us how to go through all the different options for what do we want to choose to connect to our application. And then once you hit confirm settings, it will go and deploy that application for you. And then inside of the settings here again, it's live logs is the main thing pretty much you'll probably spend your time on at the very beginning because everything always works the first time you deploy it. So live logs is the place to see everything working, or possibly not. But thank you again to everybody for listening, and I'll take any questions that you all have.
Wow, thank you, Mikaela, for the live demo. It looks very simple, actually. We had a couple of questions. Janice, maybe you can ask your question yourself because you're there too. you were the first one.
I'm fairly sure she already answered my question during the presentation, though. Basically, my question was, does the database URL already get added by Fly when you create a Postgres database? But I saw that you said later down the line that when you set up your Fly app, you can decide if you want a Postgres database or a different database, and it sets up the URL in your secrets.
Yep, exactly. It does set up the database and connect it to the Fly application, so it gives you that proper URL. I believe you cannot actually see that URL like in any of the Fly like terminal or anything, or within the GUI. I so far haven't been able to find it, and because of that, it's just like it exists there. And then if you were to change that URL, like you can set the secrets yourself, but you can't actually view what is currently there.
All right, thank you.
There was a question from pixel.science as well. Can we deploy a Docker Compose with our own DB image?
Yes, you basically anything that like you can make with Docker when you just put all the things together to make any kind of Docker image, you can deploy that to Fly. The hard part about that is it goes down into like how well you know Docker for what you kind of can do. Because I personally know it well enough. I can be dangerous and like, do some things, but after that it's like that's where I get a little lost. But if you are good on making your own custom stuff, you can 100% put it all together in Fly.
Did you ever successfully configure uploading and saving of image in your Fruitful app? If so, what method did you end up using? Maybe you can explain what is your Fruitful app.
Yes. So for everyone who's wondering, I have an app that's called Fruitful. It is for connecting with people at conferences. And with this, it's you have two different people who download the application, and then when you connect together, you then make like a friendship, and then you can just see that person's contact info, like their social media, like nothing like their phone number or like email, nothing like that. Just like here's a list to their social media, so it's like a digital business card. And the part that I was working on was adding an image to that, because I was struggle busing getting an image to connect, and I actually deployed mine to Heroku as opposed to deploying to Fly. And because of that, both of these platforms have, what are they called? What is the word? Oh my gosh.
S3 storage?
It's ephemeral builds. That's it. So every time you build something, it's not always going to the direct same machine. And because of that, you have to put your photos or whatever else, like files, somewhere else. So I did figure out how to put the photo on, I was deploying to, it's called Bucketeer with Heroku. I was able to do that, but the thing I was debugging forever was I was using the wrong URL. I spelled it wrong. So that took a couple hours of debugging. But then after that, I was able to successfully post the image up there, and then now I have to save the image, but that also means I have to get the AWS permissions correct. So that is actually going to be my talk that I'll be giving at the Server-Side Swift conference this year, which will be like posting your images and then downloading them, because it took way more debugging than I would have guessed for that. But I have halfway figured it out.
And the Swift Server-Side conference this year, it's in London in September. I don't have the date in mind.
26.
26. I'll search that for, I'll put that in a banner. Two more questions. Do Fly have lower tier than 256 megabyte of memory?
Yes, Fly has, where the URL go? It has, they do have one lower than 256. I saw it. I'm trying to find where, or do they not? Am I lying? I'm lying. Okay, just kidding. I believe 256 is the lowest that they have, according to their pricing sheet that I'm looking at right here. So when you go to, whoops, fly.io/docs/pricing, then that has all of the information, and it looks like, yeah, 256 is the lowest.
Is the smallest.
From what I can see so far. But I want to say I totally saw maybe a lower version when we were going through it initially. So if you watch the recording, then there is a lower version. Otherwise, I'm lying, and it's only what's in the docs. But if you find it within the settings, then and you change that, then it's basically everybody can always update the docs, because they are open source on GitHub. So you can just click like edit this page on GitHub. You can always correct any of the docs that you're like, this is super confusing to read. Like I was going through here and was on Postgres. Like these docs right here for connecting to Fly Postgres. Every single one of these says access Postgres from the terminal. And it's like, that's not helpful.
Yeah,
that's not what you're looking for. Then you have to go somewhere else. So all the docs are open source. Maybe I'll put up a PR to fix that, because I find this annoying. But the docs are like the main place to find that. But I think then 256 might be the lowest RAM.
With 256 gigabyte of RAM, we can cache your entire DB, says Pixel Science. I think the last question will be difficult for us to answer. How many companies are using Fly and Vapor in production? Nobody's working for Fly here, so we don't have this data. Maybe you have some clue?
Yes, on the website they have, where'd it go? A bunch of companies they listed here that were not listed the first time I did this. Could have sworn I saw it. It was a big list of companies.
Like their reference customer or something?
Yes. Yeah, so they pretty much since 2022, a lot more companies have been partnering with Fly. I think because of the whole issues with Heroku, and it was actually funny, one of the questions on my talk from 2022 was somebody was like, how long can we trust Fly? Because as we've seen with Heroku, they got rid of their free plan. How long will Fly have a free plan? And It seems like it lasted about a year and a half or so, a little less because I know that they took away their free plan earlier than what I had originally said too. So it's they have way more integrations, I would say, than they did 2 years ago. But as far as like actual companies that are using it, I'm not completely sure. I could have sworn I saw a page on it here because I was clicking all through their like website earlier. I can't find it right now.
That's okay.
But
We'll
it's
find it.
yeah, it's they have way more integrations now than they did 2 years ago, so it could be a more viable plan for you to use Fly. But again, it kind of goes back to how well versed you are within Docker.
And then you have some love about
Aw.
Fruitful, about this presentation, and I also show your the address of your YouTube channel. There are tons of other videos like this one and demo, so go there to discover the content produced by Mikaela. Mikaela, you will be talking at a couple of conferences across the world as well in Q3 and Q4. In Europe, you mentioned the Swift Server-Side conference in London in September, but you are already planned for others as well?
Yes, so this year I'll be speaking at least 3 conferences. It's already Server-Side Swift in London, SwiftConf in Cologne, Germany, INES Spain, and I can't remember the city name in Spain, and then possibly one other, but yeah,
I can't remember this. I cannot remember the city name in Spain. It's a small city in the middle of nowhere. Oh, sorry, in between Madrid and San Sebastian. That's large area. Thank you very much, Mikaela, for your talk. Stay with us. If we have more questions, we can. We can answer this question. And thank you, Frank, on the chat. You remember us the name of the city for INES Spain. It's called Logroño, and pardon my Spanish accent. It's worse than my English accent. Next on stage, we are going to talk about Hummingbird with Janice and Adam.
Hello, I'm Yanis, this is Adam, and we're developing the Hummingbird framework. You want to introduce yourself a little bit, Adam?
Hi, I'm Adam, open source developer. Nice logo, yes. I'm responsible for most of Hummingbird, and then also the Soto, the AWS SDK unofficial one, and the VS Code Swift extension. I've been quite busy. Anyway, this is to present what will become Hummingbird 2. I'm going to leave Yanis to do the first part.
All right. I'm Yanis. I'm also involved with Hummingbird, MongoKit, and some other database drivers such as Redis Stack. And we're both also members of the Swift Server Work Group. All right. So, both. So we're talking about the Hummingbird 2 framework. We're going to be giving you an introduction into what the framework is and how we leverage Swift. So first, for those unfamiliar with Swift, so most in the chat is familiar with Swift, but some reasoning why we think Swift is a good choice for backend deployment. So Swift on the server has been around for a long time now. I think 2016 is when I got engaged with server-side Swift. And most of a lot of the features that are named here, mainly memory safety and performance, were a bit less than they are now. I thought it was an excellent choice back then. I think it's an even more excellent choice for backend development now. Swift has memory safety, and I think that's a really important aspect for a server. So one of the main things you want to do when you have a server is you want to deploy it in like a Docker container, let's say on Fly, and it's handling requests, and it could be handling 1 request at a time, but it could also be handling 10,000 requests at a time in your system. If an application crashes due to memory safety concerns, which is the most common type of concern when it comes to crashes, not only will the current request fail, but all of the running requests will stop executing because your application crashes. So for server environments, having a robust, predictable, and safe environment is even more important than it is on iOS. when you're handling a lot of requests, you want the performance code base. Just-in-time compiled languages, especially those with garbage collectors, can have good performance throughout a regular execution cycle, but they get performance spikes when the garbage collector needs to clean up. ARC, automatic reference counting, is a lot more predictable than the alternative garbage collection methods. And manual memory management is not the optimal choice because then you're very prone to mistakes and memory safety issues. Swift has a low memory footprint, as was mentioned in the chat previously. Fly offers a minimum tier of 256 megabytes of RAM, but I've run servers in Docker that use 64 megabytes of RAM, which is considerably cheaper. Finally, Swift thread safety and ergonomics. Swift thread safety ensures that you have you eliminate the null class of race conditions, and thanks to Swift structured concurrency and ergonomics, it's also very predictable and easy to write code that is understandable for you as a developer as you continue developing your Swift code. So what is Hummingbird? Hummingbird is a web framework for Swift focused on HTTP requests. We support HTTP 1 and 2. We support TLS and WebSockets, so the entire package of HTTP development is available in Hummingbird. We have your common routers. We have your common routers for routing requests, so that you can plug in a handler for. You can plug in your own routing mechanism, for a proxy server, but you can also use API-style routing for your common use cases when you're doing APIs. In addition, we support a variety of integrations with external packages in the ecosystem, some of which we'll be touching upon later in the presentation. A couple examples include the Open API generator, for example. We even have AWS Lambda support. So why would you choose Hummingbird? So previous frameworks that I even was involved in creating existed in a time before structured concurrency. This made it very hard for beginners to enter the scene when it came to concurrent programming, because event loop futures, flat maps, and all of those complex operations make it hard to reason about your code or get started with software development in Swift. So Hummingbird 2 completely embraces structured concurrency even throughout its core, making it extremely easy to read, reason about, and even easier to optimize in performance. So Hummingbird, in addition to being embracing structured concurrency, is also modular, meaning that we build out we have our ecosystem built out in separate modules. So some of the modules are packaged with the core library Hummingbird, but you don't compile what you don't need. If you're building a simple web service that doesn't need WebSockets and doesn't need HTTP2, you're not paying in binary size, you're not paying in compile time. Finally, we integrate with the latest and greatest technologies in Swift. This includes distributed tracing, the observability stack. We support Swift Service Lifecycle, including their graceful shutdown handling. And argument parser is another one that people generally like to use with modern CLI applications. So to get started with Hummingbird, and we're talking about Hummingbird 2 because it's the latest and greatest that is coming up. The first thing you have to do is you need to create an executable target. We have two ways of deploying starting with a Hummingbird application. You can either create your own new package and add a dependency, or you can use our template repository using the script shown below. We also have a lot of examples on our GitHub pages. So whether you're integrating with Fluent, whether you're doing AWS Cognito, or you're integrating with MongoDB and GridFS, we have examples for a lot of different scenarios that people want to get started with Swift on the server. I'll hand it off to Adam.
Hi. So, Sebastian, you want to? Yeah, cool. I'm going to quickly create a Hummingbird project and then show you it running. We're going to use the template method that was at the bottom of the last slide. where we have a template GitHub repository, which we clone. And then we use that template to configure a project. Let's call it demo project. What do you want my name? Yeah, we could package name demo and the app executable name is app. So if we list now, you'll see that we have a demo project folder. So if we go into demo project and kick off VS Code, yep. I'll give you a quick tour of what the template generates, and then we'll kick off a build. So first, there's a package. Obviously, it's dependent on Hummingbird, currently the beta for 2.0, hopefully a release candidate very soon, and Swift argument parser, because that's just great for our passing arguments. So the entry point for the application is a async possible command from Swift argument parser. It has 3 arguments: a host name and port for a bind address. Whoops, let's keep that out of the way. A log level, and then the run function, which builds the application and then runs it. So if we go to that function is inside application plus build. Large chunk of this is just setting up the logger, which is extracting the log level either from the arguments or from an environment variable. But the actual application, which is the important bit here, is we create a router, we add a middleware to the router that will log requests, every request that comes in, and we add one endpoint, health, which just returns OK. Then from the router, we create an application. The application joins the router to the server. The server is, by default, is set up to be HTTP 1, but you could do this instead if you wanted to be clear about what you were starting up. So I will kick a build off. And it shouldn't take too long, given it's normally about 15-20 seconds for a simple app. While we're at it, we'll also set up a separate, yeah, there we go. So that's the build complete. So if we run it, you see it. Oh, so you can see it's just basically this is the output just so far. It's just telling us there's a server running. So if we go back to here and run curl, we should see a result. There you go, and that's it, returning the 200 response that we expected from the health endpoint. The router has quite a few features, but I'll let Yannis go back talk about that. If we want to go back to the slides, Sebastian.
Yeah, so we have a router system similar to that was present previously in the ecosystem. When you create a route, you can register it with the on function and then a path component, then your path component. This is just a single string, and we can use path parameters in there. We can have any path parameter in there. We can capture parameters. We have prefix parameters where you want only to capture only a part of the path component, and we even have capture recursive wildcards. So you can select the method which you want to capture on that route, on that path. And then we have two arguments in your route. We have the request and the context. The request is your simple HTTP request. It contains your headers, including the method, path, parameters, and your HTTP body. HTTP bodies in Hummingbird are always asynchronous, but you can still get conveniently access to Codable and other stuff, other integrations with the ecosystem. The second bit is more interesting, I think, this diverges from previous implementations in the ecosystem, which is the context. The context, we'll get into it later, it contains the, let's say, the socket information, the channel on which your API, your HTTP request entered, for example, the IP address of the remote peer, etc. You can add a lot of information in here. We'll cover that later. Hummingbird 2 supports threshold concurrency, which means that you can use try await, all of the niceties here. And you can, we have helper APIs for on that allow you to get, reduce the on request into get, which is the same thing under the hood. We also have a secondary router, which is the router builder. But I think that is, here are some examples of capturing anything, capturing a parameter. I think this is old syntax actually, isn't it? This was supposed to be a column, wasn't it, Adam? You're muted.
It's a page of parameters detailing the parameters. There's nothing on the router builder in the slides. Sorry.
Okay. Yeah. I'll hand it off to Adam here before I dive too much further.
This is good. Okay, so we're going to. I will show you how some of the parameter stuff works with the router. So we will do a new route using the and what we're going to do is call it hello, and it's going to take the parameter name. So then, and now we have to basically what we can extract the name from the URL using this, which is basically when you have parameters in the path you're matching, they will get passed into the context, into a parameters type within the context. So with that, we can then just return hello and name. And so hopefully that if we rebuild that, while Yanis was talking, I added in a function to add endpoints to the router. And so if we go back to here and this time it's a post, so that's next post. And it's basically, yes, return the hello Yanis. We also use the open API format for parameters. You don't need to use the colon format. This helps us because then we can also do prefix and suffix parameters as well. So in this situation, this is a single path component. So if we instead rerun that again, and it's up again, and so it will extract the Yanis from the Yanis.txt. Yanis didn't actually show you the slides for the request decoding and response encoding. this is similar to Vapor, where you can basically set up a type that the request will get decoded into, and types for the responses will get encoded into. I could see if I can get a quick example. We'll do this groundbreaking server, which is going to basically take some text and split it up into its list of strings. So text split request. This is basically a type which has got. Oops, I can't type that. And then it has a response. And so if we can use those to just use burst again. And so to decode the request, we would go as, so we want to decode it as the text split request. Doesn't like that for some reason. All right, yeah. So we are then going to create our words, which is basically, let's see if I can get this right first time round. So that's basically splitting the text into words. This isn't the important bit in the end, but like, and then we return so if we build that,
you need to make it codable.
Yeah, of course, that's the important bits. Yes, the object decoding and encoding, obviously, it does use codable. So for the request to be decodable, it has to conform to decodable. For responses to be encodable, they need to
Response encodable.
They
need to be response encodable, you meant.
Yeah, they need to conform to response encodable, because that defines how you generate a response from this type. Internally, it uses encodable to do this. And so, oh yeah, we forgot to put words. And now, if we build that, and we go back to here, I've got to try and hold on, HTTP split minus D. This time around, we need to post some.
I'm surprised you can remember these.
Yeah.
During a live demo.
Yeah. Maybe I should have used Rapid API. This is a test. And if let's see if this works. Yep. No coding key not found.
Text.
Okay. Text. Yeah. Text. There you go. And it's managed to split it up into the individual words. So basically you can take any type and any codable type and use it as a request type. By default, it uses the JSON decoder and JSON encoder, but you can set it up to use whatever decoder you want. So you can use URL form type. file types as well, or whatever, XML, if not many people seem to do that now. Anyway, I'll give you back to Yanis, who's going to carry on. You've showed the slides detailing this now.
No, yeah, it was in between, but I skipped it already. So Hummingbird also has middleware, just like Vapor. I wanted to say, I'm sorry, I used to do years of Vapor. So out of the box, we have a couple middlewares provided. We have a file serving middleware which can integrate with any type of file system, including, for example, S3 buckets, MongoDB GridFS. We have middlewares for observability, which use the best practices as recommended by us, by the Apple guys and other Swift server workgroup members. We have course middlewares, but you can also very easily make your own middleware or use one of our extension libraries, such as Hummingbird Auth, to implement authentication. The most important change in Hummingbird from other frameworks is that we have the request context. The request context provides contextual data that is attached to the request, but the context can be modified. So we have provided a default request context out of the box, which is called the basic request context. The basic request context contains information such as the maximum amount of bytes that your body that your HTTP bodies can be when processing it, when collecting it. Another example of a request context data is the JSON decoder that you want to use for this request when you use Codable. But you can also add your own bits of metadata here, such as JWT tokens, the authenticated user, and you can modify this as you deem relevant. Middlewares and the router pass along the request context generically, so you can make a middleware that requires a context that conforms to a protocol. For example, you can create a middleware that requires being able to get and set user data inside of your request context. You can also have a proxy middleware that registers the IP addresses of all the peers involved, either the remote server or the one that your client is connecting on. The request context is intended to provide additional metadata about processing and creating the request. The request context is explicitly not intended to be a dependency injection mechanism. So don't try to use it for that, because it's not going to be more ergonomic. The way we recommend dependency injection is explicitly. So you can create a controller as a structure class. You can store your data or actor. You can store your properties, for example, a request counter in there. In a middleware, you can have you can inject your databases into your controllers and access those properties from within the type when you register the route as a function. Here's where I hand it off to Adam again.
Okay, I'm very quickly going to try and set up a context and show you how it can be used. This one is my stupid authentication. Basically, I've already set up, while Yanis was talking, I set up the base context. These are, a request context has to conform to the protocol request context. And its requirements are that basically it has this member variable called context, and that it can be initialized from an associated type called source. In this situation, it's an application request context source, which includes the channel that the server that created the request. So that's the basis for your context. After that, I'm going to add in a new variable, user. And then I'm going to create a middleware that's going to edit this context based on something based on the request, and then pass that on to a handler. One other thing to point out while while Yanis was talking, I also did this. When you create your router, you define what request context you want to use within the router. So in this one, I've set up the request context that I set up below. Okay, so let's make a middleware. I've got a wee shortcut here. This shortcut sets a middleware that will work for any context that conforms to the request context, but we want it to just be for this request context because we're actually editing values in it. So what we're going to do is type alias and get rid of this. So at the moment, all that happens in the middleware is it passes the request and context onto the next handler. So what we're going to do is take a copy of the context so that we can edit it. And then based on something in the request, let's just make it if request.uri. Let's one a query parameter called user equals me. Then we'll set the context. This is obviously completely fake and not how you would do any authentication. So now when this middleware is called, it will basically, if we send in the parameter Adam, it will set the context of the user to be Adam. Otherwise, it will set it to be nil. So in our router, we can add the middleware. And then we'll add, well, we'll do it in the same line. And I'll just use it. New endpoint. And we'll just basically go guard if context a user. Did that work?
Guardlet, you mean? Or...
God if. Yes, this is the. Else, what we'll do is if it's not, we'll just throw that it's unauthorized. Otherwise, return Adam. We'll throw it, not just leave it there. And we will run that. HTTP error, whenever you throw those, you get basically, you can throw the response status and a message that will get included in the error if so desired, and they will get caught higher up and get converted to a proper response.
You can also conform to the relevant protocol. Can you hover over HTTP errors to show the protocol? So HTTP error conforms to HTTP response error, which you can conform to as well to implement your own errors that get called and converted to a response.
So
the
now,
most important errors that you can encounter from Swift Neo are already covered.
Yeah.
For example, if the HTTP body is too long for the input, and the route doesn't want to process that long of an HTTP body, as a protection measure, we'll have a limit by default that is, I'm not sure what the limit is off the top of my head, but there's a limit to protect the routes against accumulating all the memory.
When you are, if it was a body, I'll do this in another. If you did have a body, you would basically. No. It's because this just uses a neo function, which is body. I cannot request dot body, and then you collect it. Basically, that request.body is a stream of byte buffers. If you want to collect that into a single byte buffer, you would then you can define at that point how large is the maximum for that buffer. And if you go over, if the request goes over the size of that buffer, it will then throw an error which will get converted to the correct HTTP response further up. Anyway, back to my cheap authentication, which just basically checks I've sent. So there we go. Was it? No, it's get. Oh, we're going to a website. And that should. There you go. That turns Adam. If I put it in, then but Johannes is not. It's not. So this is basically showing how you can pass information from your middlewares to your endpoints. Obviously, doing proper authentication is a lot more complex than that. We actually have a separate package, Hummingbird Auth, which does provide you a lot of helpers, so you can set up different authorization methods through middleware. And at that point, I think I'll pass back to Jannis.
Mm-hmm. So Hummingbird has the router that we just showed you. At the core of a Hummingbird Hummingbird application is the application type. This type is generic over context and other information, and you can pass in the router that you created to set it up easily. In addition, you can provide the server parameter, which you can use to use a TLS in addition to standard HTTP1, which is the default. You can also use the Hummingbird WebSocket library to connect with WebSockets here. And finally, we have AWS Lambda support as well built in through the server, a customizable server interface. When you run the app, you run it through the run service function. The entire setup of Hummingbird uses Swift service lifecycle, including graceful shutdown. This means that when your Kubernetes or Docker container gets interrupted and wants to stop, existing requests will be handled, but no new requests will be accepted and no new connections are accepted. This ensures that the server continues finishing the work that it was doing, but also that it stops accepting new work so that things can shut down and we can, for example, do an update of our API. Swift Service Lifecycle also is used by other libraries. For example, I believe Postgres Neo uses Swift Service Lifecycle, or can use Swift Service Lifecycle to register itself. And you can register those services on Hummingbird as well, or you can use Hummingbird as a service as well. We talked a bit about modularity. You can compose some server HTTP server backends. For example, you can use the TLS function combined with the HTTP1 function to host an HTTPS server. That works by changing the code as so. The TLS configuration is something you would need to do yourself based on your own certificates. Finally, we have AWS Lambda support. This does not use the application code, but instead uses an API Gateway Lambda function or API Gateway v2 Lambda function protocol implementation. This sets up the Lambda using AWS Lambda runtime by the Swift server organization. And in here, you can create your own responders that use the same methods of interfacing that the rest of Hummingbird does as well. This can be really helpful to deploy a lightweight, use-on-demand HTTP server that is very cheap to host and only does request response. So AWS Lambda does not support, for example, WebSockets out of the box. Finally, we have a lot of resources that you can use to get started with Hummingbird. We have, of course, our GitHub organization, the Hummingbird project. We have documentation on docs.hummingbirds.codes, which currently still points to the version 1 documentation, but we'll be moving that to Hummingbird v2 documentation very soon.
The V2 documentation is up there. It's just under a 2.0 path. I should have edited.
But we'll be making that the default very soon.
Yeah.
Finally, we have the examples for Hummingbird, which include a lot of different use cases in which you want to use Hummingbird. Some people are using Hummingbird or V2 already to create HTTP proxy servers with authentication, and you can use the streaming HTTP bodies, because bodies are streamed to efficiently upload data to the remote without using a lot of memory. And finally, we have the Discord server, which you can join if you want to connect with people, ask questions later down the line, or just generally get involved with Hummingbird in any way, shape, or form. That's it. Thank you.
Wow. Everybody has been really impressed by the live coding and the ability to remember all the parameters for a curl command. There is a lot of...
I sure can't.
There is a lot of questions. There is one elephant in the room, and the question has been asked 2 or 3 times. What are the major differences between Hummingbird and Vapor? Maybe is there like a decision tree to choose one or the other? I don't know. How do you see the two frameworks that looks very equivalent, at least on the purpose, why they are there?
I would say, well, Hummingbird is, well, obviously first it starts with, it's more modular. So when you use just the basic HTTP server, all you're getting is the HTTP server. Vapor has everything. It's you straight off. So you're paying for everything all the time. Meanwhile, with a Hummingbird, you are compiling just the code you need.
That also means that you need to choose the components that you want instead of getting everything out of the box. So it can be a little bit more of a discovery what requirements you have and what the framework provides and what plugins you need to get. So basically what modules you need to add. But it makes it very explicit what you're using, what you're compiling, what you're paying for.
The second point is Hummingbird 2 is built off Swift concurrency. Its internals are all Swift concurrency. It's a modern framework. Well, most of Vapor 4 was the internals were written five years ago, and they have put on a lot of Swift concurrency features, but they can't do certain stuff because they're held back by the fact that they're still dependent on Neo event loops.
This one is not a question, it's just a comment from Jesse that said he's running Hummingbird on embedded Linux device. And he's impressed by the performance there. I'm going through the list of questions. Joseph loves, it's not a question, it's feedback about the built-in observability feature. Oh yes, we have Sliemeobian, I'm not sure I'm pronouncing correctly, he was so disappointed by the light mode on Visual Studio Code. And Janice said that here in Europe, at this time of the day, it's still day. in June. Andrea was asking, what's the advantage of putting a framework such as Hummingbird inside a Lambda function?
So from my perspective, normally Hummingbird would be a long-running service, right? So you want to, it's most efficient that way. Some customers that I have had in the past, they really don't need that many resources for all of their backends. So they would much rather have something like Fly, where it suspends after a while and you stop paying, or something even more lightweight for just a few requests that come in, like an AWS Lambda. The problem there is, from my perspective, is that when your application does eventually get used a lot more and more features are getting added to the backend, with Hummingbird 2, you get the luxury of just swapping out some components, but not the entire ordeal. So you don't need to migrate your entire code base from AWS Lambda to a Docker container or like a long-running service. you can do so it is a very lightweight step upwards to migrate an existing AWS Lambda service on Hummingbird to an HTTP1, HTTP02 server, maybe even with WebSockets.
So yes, if you develop your application for Hummingbird, you have the options with minimal code change to deploy on Docker/Kubernetes, Fly.io, Lambda, and other. You just need to change the transport, but all the application logic stays the same.
Yep.
Very clear. Talking about the templates, do you support dev container? That's a question that came during the last meetup already. Looks like there is a lot of work for dev containers.
Yes, we do, but I don't think we have it in the template at the moment. But it's very easy to set up a dev container. You can, within VS Code, you can just right-click on. I can't remember offhand the name of the function, but the command. But there's I think it's build dev. Oh, have you got my thing now? See,
yeah.
What I would I would click in the corner here. If this is my cursor, there's a wee pink icon at the bottom, and then there's a reopening container function, and I'll just add configurations to workspace. Then you go from predefined show all thing type Swift. We'll use 510. Okay, and that's basically it. We are now running. Well, when it gets, let's see how long it takes now. Doesn't always. Sometimes it's quite fast. Sometimes it's. But this is it setting up the dev container just now. Luckily, I had 5.10 installed.
Okay. Talking about the length of the compilation, there was quite a discussion while you were talking about the initial 42 seconds for compilation, which is faster than Rust, but slower than interpreted language like JavaScript. And then we show in subsequent rebuild that you did only the change were recompiled and the recompilation were much faster. I don't think there is really a question on that. It was more like a thread going on while you were talking.
Well, yes.
Yeah.
Swift Neo will only be compiled once. It's not going to get compiled every single time now. Because Hummingbird's modular as well, the compile times are considerably reduced to a certain other server framework on Swift. While we were talking, this is now loaded up. This is now running on Linux on my Mac. So that was fairly easy. That was fairly quick to get a container up and running.
Question about dependency injection. Can Hummingbird coexist with dependency injection? How could you call a service to handle requests on a specific route?
I'm not sure I understand the question of the message of handling a request from calling a service to handle a request. But I think Adam wanted to take on the dependency injection bit.
With the dependency injection, basically, the way we would do it is, I think it was pretty much how Yanis described before, where you would have in your controller class, which has all your endpoints in, you just add in the dependencies you need. So if you need a Postgres client, your controller should have a reference to the Postgres client, and then these will get used by the routes within the controller.
And if you want mocking, then you could create a protocol that captures the functions that you need access to.
Yeah,
and that's how you would do mocking.
There was another question about dependency injection. When you were talking about the middleware and doing the middleware demo, do you treat the middleware as dependencies for DI?
No. So middlewares modify the request or context, or they enrich it by providing an early response, an early exit, or by verifying some information about a request or context. But they're not necessarily dependencies, although you could keep a reference to a middleware, I guess. And that would work for example, request counting, I guess. Although I would personally use metrics or something similar for that.
There was two questions about task local. Question from Anza: why isn't the context a task local, since it's the extra info that many handlers won't use?
We considered that originally, but the main reason that I think we decided against that is because we want request context to be generic. We want you to provide a type conforming to protocols that you can use. That way we can also have the middle where this is specify not a specific request context, but a protocol conformance, and you can hook into that protocol conformance.
Is there a way to stream large JSON, like decoding while the JSON was arriving? I think there is a bit more context in the next message. Streaming request of a file that's hundreds of megabytes huge. Can I extract values from the JSON as it is streaming rather than loading it all in memory?
With the Swift JSON decoder, I'm not sure that would be possible, but I don't know if, to be honest, with Ikigai.
Yeah, Ikigai JSON does have some preliminary support for that, but it's not quite there yet. It's been on my long-standing list of things to do, but it's close enough to being ready, but not quite.
Okay.
If there's more demand for it, I will make time for that, of course. But
can you specify multiple contexts for use on different endpoints?
Not at this point, no. It has been. I have considered it for grouping endpoints. If you have a whole bunch of endpoints underneath an authentication middleware, then provide the additional data needed for the authentication middleware at that point. But at this point, you can't.
I'm switching back and oh, go ahead. Sorry.
I do think, but correct me if I'm wrong, Adam, I do think that we have the infrastructure that we could probably enable that down the line, but it's not currently a goal.
Yeah, it wouldn't be too hard to implement that.
I think it's a good question.
Switching a bit back and forth between subjects, but I'm taking the question as they appear, otherwise I'm going to lose track. Tibor had a similar question about the difference between a context and a task local value.
The context in Hummingbird is a generic type that you can specify. Task locals don't really provide us with that level of type safety that we need for this. So with a task local, you create a property wrapper, basically, that you specify a type in that you want to represent within your task locals. And then you can set that task local for a scope of code, that scope of code is achievable, right? Because everything is structured concurrency. So you could expose task locals from within middleware in Hummingbird, or even from the HTTP server side if you were to override that behavior. But because the task locals are generic from the Hummingbird framework perspective, we wouldn't be able to leverage those.
Do you detect, or Hummingbird runtime automatically detect the number of threads it can run, or is there a way to set this manually?
At this point in time, because we're reliant on Swift concurrency, we don't have a great deal of control over this. In the future, once we get task executors, we will have a lot more control over it, and you should be able to set the number of CPUs a server could occupy.
So that would, I think we already have a PR that's pretty far along, but of course Swift 6 isn't out yet. But we have a PR ready for Swift 6 that we can merge at any time, where we use the Neo event loops as the task executors. You can even already in Swift 5.10 set the Neo event loop group as the serial executors, basically the global concurrent executor, so that all of the structured concurrency code would run on those event loops. In Swift 6, we would get the ability to specify that the request runs on a specific event loop, which reduces thread hops and a lot of other performance overhead. But we would want to wait for Swift 6 to arrive a bit further before we merge that. But by then, you can create an event loop, let's say with 4 threads that you specify, or the default that Neo has, which is the amount of CPU cores available. And based on that, we could decide how many cores we allocate for Hummingbird.
And I think it was the last question. The rest is a lot of good, positive feedback about the presentation, the demo, the framework, the clarity of the answer. There is a discussion right now going on between Anza about live decoding of JSON. Okay, let's finish this meetup by bringing everybody on stage and answer any questions you might have about the Swift programming language and Swift on the server. I have a few new guests as well. Sven is there. Well, how can I get everybody on the screen? Maybe like that. So Sven, you're running the package index, amongst other things. There is Tim from, amongst other things, Vapor, and you were speaking at the last and the first meetup. And we have Franz as well.
Hey,
Franz is part of the Swift server working group working for Apple. Did I forget someone? No. I guess everybody is there. So let's shout out your question in the comments, and we are here to answer them. Maybe someone wants to comment on the DC, the recent announcement, or one of the two conferences that we had tonight. Okay, so if you're doing questions in between you.
They are only coming out for special occasions.
I told you already, but the part that impressed the most, that impressed me the most, is that you travel with that to Cupertino to record.
I had to get it from back home and bring it over to Cupertino.
Jesse said, thank you. Looking forward to doing more of it in the future. While waiting for your first question, the next one will be in September, probably at a different time of the day because we'll have a speaker from Japan. So we'll probably shift a bit earlier during the day, which might be impractical for folks in the US. But as usual, these sessions are recorded. They stay available on YouTube. And so you can watch them offline. Anyone from the panel willing to comment something from the talk tonight or from the DC? Because it looks like we don't have a lot of questions coming right now. Nope, okay.
We can't just talk about the Lederhosen. Yes, there are many folk fests in Munich.
Once you put that out there, you got to live with it.
A DI question. Service lifecycle seems to be difficult to use with dependency injection. You need to respect order.
So I can take that one.
We're speaking up, so I'm going to put you up there.
So yeah, I can take that one. I think service lifecycle is still not finished. So there's a bunch of experience that we have to get in the ecosystem. When we put it out there, it was more about solving what the old service lifecycle did, but in a structured concurrency world where we had to completely rethink the patterns, how to start up services, how to structure your applications. We have seen a few patterns used in the wild to have dependencies between services. But recently somebody opened a GitHub issue, I think it was Fabian, about having the possibility of adding services late after starting the group already. So you can form these dependencies. And I've also been toying around with some ideas of, using a DSL-like syntax to build a dependency tree when you declare your service group. And you can inject one service into the other one and wait until it's running. The tricky bit here is we need to basically know once a service is running. Since everything is asynchronous and potentially runs in parallel, we never know when a service is running or is ready to get requests or be interacted from other services. So we kind of have to expose this. If you have any concrete examples in mind, please drop them in a GitHub issue and we can discuss them there. I think there's still a lot more we can do with this library.
Thank you, Franz. How big is static Linux linking. I made a couple of tests this week. I'm not sure I did the test right, so maybe there is some optimization, and I've been chatting with Janice and Alastair wrote the static Linux linking, but a simple print hello world generate a 40 megabyte executable. But again, all the static libraries, including the Swift runtime, but also the libc library are included, which explain the size of the binary. And then I don't remember who, I think it was Alistair, suggests me to strip down, to use the strip command to remove all debugging symbols from the binary. And out of my memory, I think it went down to 8 or 9 megabit. So it was quite important reduction, but still much more than the 40K or something if you use dynamic linking. So enough, sorry, I don't know, I have French words that are coming out of my mouth. 9 megabytes for Hello World. There is a discussion right now on the forum as well about stripping the additional libraries that we are linking to the binary, because when we are using some compiler techniques, it's only applied to the code that we are compiling, not to the libraries that are being included into the binary. I don't know if someone has something else to add, Franz.
So I think in general, static linking is coming along nicely. I think one thing that I've been trying around sometimes is like using the various LTO flags. The embedded mode, for example, they do quite a lot to get binaries down, right? And I think over time, once the embedded mode flashes out more, we can start to pick up more of their flags for compilation and for dead code stripping to reduce our binary size as well. I see kind of Swift embedded mode as like a spearheading function to improve the code size.
A question about what excited you the most. What excites you, sorry, the most for Swift on the server? I was trying to understand the SOS acronym, Swift on server, for this year.
Should we do a round?
Yeah, go ahead. In the order of the image on the screen, on the thumbnails.
It's okay. On my screen, I'm first, so let me start. So I'm most excited about the ecosystem coming together around structured concurrency. You know, Swift on server was always capable of being high performance and implementing the business logics that you need. But the fact that you had to handle new event loop futures and bringing in a completely different paradigm was making it challenging for new people. And now being in this one unified concurrency model across all platforms truly unlocks like great user experience, but also a really great interop. Like you can just easily, for example, pipe bytes coming from a request into a file or into a Kafka stream, and it's just all the same APIs in Swift concurrency. And I'm really excited about all of this coming together.
Adam? Oops, looks like we lost Adam. The image is frozen. No, you're back.
The release. Yeah, I'm back. The release of Hummingbird 2, obviously. But it's kind of in line with what Franz was saying with the move towards structured concurrency, and slowly with all the components moving together. It's quite exciting seeing everything coming together. I look forward to Vapor joining us.
Chinese?
So, of course, Hummingbird 2 excites me a lot, but I'm personally also really looking forward to the tutorials and guides that we've been putting out. If you're not familiar, we have the Swift on Server website, which various people in the, like Tibor, for example, is also involved with Swift on Server. We're doing that together, but there are a lot of other people that might also be in the chat right now that were in the talks with about writing articles together on their libraries or their experiences with Swift on the server or structured concurrency even. And we've been putting out some good content, I feel. The quality is where I want it to be. In the Swift server workgroup, one of the main goals that we have had this year and previous year as well, but especially this year, is not necessarily to improve existing libraries, because those are getting there. I'm really proud of what's there. And I don't think that when Hummingbird 2 is out or whenever, we don't really have that much that we want or need to upgrade, but it's mainly examples that are missing. It's mainly documentation that is missing, tutorials. How do you combine these tools that Francis talked about, right? So how do you pipe? It's very easy if you know how to pipe data from an HTTP request body into a file, but having that base level of knowledge on structured on the ecosystem is still pretty hard to achieve for the community, we found. And we've been steadily improving that, and I'm really proud of that. And looking forward to where we get later this year.
Tim?
I think Vapor 5 is going to be a big one for me, which will kind of be a good step in the right direction for Vapor and getting rid of 4 years of tech debt, and trying to bring the ecosystem along, which would be nice. And showcasing some good. Also looking forward to the Server-Side Swift conference, obviously, and we should have some good talks there, showcasing nice technical talks and good success stories of people using it and their experiences.
Sven?
I'd say the Swift 6 concurrency checking. We have a couple of rare crashes that we see every once in a while. And I'm sort of, and they seem to be very related. So I'm hoping that once all the underlying dependencies and us adopt strict concurrency checking and make sure all the warnings are sorted, I'm kind of hoping that goes away. And then not really Swift on server specific, but Swift testing, just as a thing we'll hopefully start using soon. I'm really excited about that because we have lots of tests and the organization isn't great. So I'm really looking forward to be using the tagging stuff that they have that just make it easier to organize tests. And obviously the expectation syntax is really nice. And then just showing what's going on in a large project, a large test suite is hopefully going to improve lots of things. Once, obviously we won't adopt overnight, although that would be amazing. But in the end, I'm hoping we'll transition over and that should be great.
And Mikaela?
I'm kind of also stealing Sven's answer as well, Swift testing, but then also all the concurrency that we've all been talking about too. And just so everyone knows, I'm not on the work group, so like if you don't see my name, I'm not there. Just so you know, so you don't like freak out and be like, hey, your name's not included. But yeah, it's Swift testing. I'm excited to see like Vapor 5 and yes, helping with like get some of all the like tech debt out there and contributing like to the language itself, because like for me personally, contributing to Swift and like some more open source libraries are something that I'm excited about this year, and just the documentation that's starting to fill out around everything is super nice, so that anybody can really get started in open source development and actually contributing to all of this stuff.
And for me, is the static Linux linking, because I think it will simplify a lot the deployment on the server side, the packaging of Lambda function, for example. We don't need Docker. So I'm looking forward this space as well. Question from Joseph. Is there any pre-built middleware for observability that combines logs, metrics, tracing all in one batch? Or is it expected that we assemble all what we need as we need it? Who is taking?
I'm not aware of anything at the moment.
So I'm assuming this is about Hummingbird 2, right? So there is no pre-built middleware that does all of it, but we do have middlewares that do the individual components. Yeah.
I think the question came up before, and like not only the Hummingbird context, but also should we combine Swift logs, Swift metrics, Swift tracing into Swift telemetry? And I think as a server work group, we've been discussing this off and on sometimes, but we feel like it's a good split to have them, because some people just want to have one part of the observability stack there. But from a user experience, like I think it's totally valid if you write your own middleware that does all three in one go because you need all of it. That's completely fine. And with you knowing exactly what your application needs, that's something you can just do, and you can avoid the 3 different ones.
What is missing in the Swift ecosystem right now? And any idea when it will be fully baked? That's probably never, because changes and requirements are evolving. But what are the big parts that are missing right now?
I think you hit it on the head. Actually, I think an ecosystem can never be finished. Regardless how old a programming language or ecosystem is, it's always a moving target, and always the next new thing comes around that you want to catch up on. I mean, we see it with Swift concurrency, right? It changed our whole thing. Like, we thought we had a pretty good ecosystem, and I was like, we got to adopt to async await and structure concurrency. I personally think what's missing is also reflected in our yearly goals from the SSWG. So we think that documentation and examples, and just in general, like the marketing image of the ecosystem, needs work, so people actually know that it's ready to use, which it totally is, right? There's a ton of production usage. And then it's, filling all these little gaps where people want to write their business logic and connect to the Kafkas or to the Redis or to the other infrastructure component that your company might want, and fill that in and get a community around this, so that the work to build out these components is spread across a really healthy ecosystem.
Anyone else? No? A question, I think, for you, Tim. Any timelines for Vapor 5?
Current goal is to have at least an RC around the same time as Swift 6. So those kind of timelines.
Swift 6 is here.
The Swift 6 release.
And Chris asking if you guys, so Adam Joannis for Hummingbird, Tim and Gwyn are working together, collaborating, cross-pollinating the two projects.
We obviously we have the same target audience mostly, but me and Tim work quite closely on various things, and we do. So this while we may be competing for audience, we're still working together at the same time, I think. And we do have slightly different targets in that, like, I would probably say Hummingbird is a bit more low level.
Yeah.
The one thing, sorry, I wanted to add here is, like, you can see that the collaboration has been happening for the past years since we started, right? Stuff like Swift Logs, Swift Metrics, Service Lifecycle, all of these things come from experience from both projects. And when we see something is generalizable, we try to extract it so both end user ecosystems can benefit from it. And one thing that we put up for this year's goals is also working on a shared HP server middleware implementation, right? And like Hummingbird has done a great step here and explored what's possible. And we kind of want to make this just a unified thing, maybe, or potentially, across the ecosystem. So we have one very high performance HP server, and then can build on top of this very user experience driven frameworks. If Hummingbird or Vapor adopt this shared HP server, that's up to them. But we are always trying to look if we can extract shared components.
And also, of course, reduce the work and workload of maintaining and improving those components as well, right? Because it's in all of our benefits, not just the users, but also the frameworks that we leverage, the collaborative work, right? So if we build an HTTP server, Vapor has an HTTP server, and let's say 3 other frameworks have eventually have their own HTTP server, it doesn't make sense for everyone to reinvent the same wheel.
There is one question quite interesting about why Apple is investing in the marketing and technical aspect for server-side Swift. Does Apple run server-side Swift for any of their external internal product? There is only one person from Apple here, it's you, Franz, so I'll let you decide what to answer or not. From a user perspective, looking at the WWDC keynote, it was clearly said that Apple is using Swift on the server side. One of the things that was mentioned during the keynote is the building of the sorry if I got the name wrong, the private cloud to run Apple Intelligence based on Apple hardware and Swift on the server. That was clearly mentioned during the DC. So the answer, as seen from the outside, is yes. And Franz, if you want to add something.
Yeah, thank you for summarizing this. I think you covered the parts. It's basically, Swift is not just Apple, right? You can see here in this room, it's only me, that Swift is a large community. And 10 years of Swift showed that it grew beyond Apple's platforms a lot. We want to make Swift successful in many different aspects. And in my DubDub talk, if you watch it, we are calling out some specific products that are powered by Swift on server, like iCloud products, SharePlay, or the new private cloud compute product. And across Apple's products, this is serving millions of requests per second. So it's really like a large building block. And that's why also Apple and we are contributing to Swift on server.
There is a very practical question. Where is the shared HTTP server? It took a time to react when you finished speaking, Franz, because I was looking at the package. Yes, it's on GitHub somewhere. I'm searching for the link. If someone has the link,
it doesn't exist yet.
It's not existing yet. Okay, no. So I've been confused. That's why I was.
Yeah, we are working on it. We want to see where the Hummingbird findings lead us, and we're just toying around with some ideas what we can extract, how an API could look like.
There is one very precise and specific question for you, Franz, about readiness signaling in service lifecycle.
Yeah, as I said, I was just ideating some stuff. I would be interested if somebody else wants to take a stab at it. I think, something like a result builder like DSL could work. And I'm happy to collaborate with folks who want to get into this and toy around with ideas. There's definitely some space to explore.
I'm taking the questions. Are they coming? Even if I'm pretty sure you are not going to answer this one, is there a plan to support AI from an LLM on Linux? Question from Andrea in London. No comment, I guess, from the Apple side.
You can already. There's different LLMs out there that you can run on Linux that have C bindings and C++ bindings. There's no reason why, and Python bindings as well.
Yeah, it depends what we mean by AI. Is it Apple intelligence or artificial intelligence? But you're right, Tim. It's possible to download a model from Hugging Face and run it in Swift on Linux or on macOS. Today I did that already. It works quite well. Actually, there is an open source Python package published on the Apple GitHub that allows very easily to integrate large language models from Hugging Face. It downloads the package and runs them locally. You need to have a bit of disk space available and a good internet connection, because these packages are not the Python package is not huge, but the Hugging Face models are quite large. Okay, I think I didn't miss any question. I'm browsing. Is there any companies hiring to work on server-side Swift libraries, language infrastructure?
Keep an eye out, I'd say, on Twitter and Mastodon. Vapor's got a jobs channel where jobs get posted every month or so. People are looking for to hire.
Another one from Dave about Vapor and or Hummingbird. Do you see any value in using any of the ownership Swift capabilities?
Go for it.
Oh, okay. I haven't looked in great deal at it yet, but it's certainly very interesting, and it could be interesting to see how it's like requests or. But not in any great deal at the moment.
Yeah. I think the one interesting thing is replacing C code that we currently have, especially TLS libraries. That's a very long, big project, but it could be an interesting use case for that kind of stuff.
Yeah, from the Neo side, I think Neo is a good target for ownership work, because we see in like our channel handler pipelines that sometimes byte buffers get copied around, and that just occurs like allocations. And like one of our main performance tool is always reducing allocations. So and the ownership features help with that. I've recently done some work in Swift async algorithms where I opened the PR for implementing like an algorithm and used the non-copyable stuff to implement state machines, and this worked really, really great at reducing the copy on writes and in general the copies that happen with the state in the state machine. So I think it's going to be a useful tool going forward once we can pick it up.
And looks like there is no additional question right now. I'd like to remember that there is a Swift server-side conference happening 26th and 27th of September, so just after the holiday. It will be in London in a fantastic venue. It's the Museum of Science, that's correct, Tim?
Yep, it's at the Science Museum in London,
Science
which is
Museum.
a really great venue, and it's in an IMAX theatre as well. So there's no problem with viewing code on the screen, because it's like a 30, 40 meter high display.
And the seats are super comfortable. So.
Very comfortable.
They sure are.
Thank you, everybody, for contributing to the content. Mikaela, thank you. And Janice, Adam, thank you for the great demo. Thank you, all of you that stays until the end of the second meetup. The third one will be in September as well. The date is not fixed yet, but we are going to share the date in the coming days or weeks before the holiday, so that you can save the date in your agenda. It might be at a different time of the day, as I said earlier, to accommodate some speaker coming from Japan. Have a good day, evening, night, depending on where on the planet you are, and see you next time. Bye-bye.
Bye.